Lesson 6.2 starts with a warm-up. We'll do this really quick. So how do the slopes of B, C, and AD, what are they and how do they compare? And then basically, are they parallel or not? What type of figure would this be? So first of all, if I draw this in, draw in the figure, what I see is that I have opposite sides being parallel, and opposite sides are congruent to the same length, but they aren't at right angles, and it's two different lengths. So we would have this side and this side being one length, and this side being another. So right away, what type of figure is that? That is a parallelogram. What is going on here? Now, if I want to find the slopes of, what the heck, of BC and AD, well, I know that B is at 1, 0, and C would be at 4, 1. So I run the slope for those two, and then AD, A would be at 1, 2, D would be at 4, 3. Run the slopes for those. So I would take, and we know slope is y2 minus y1 over x2 minus x1. So I'm going to take the second y, which is 1, minus the first y, 1 minus 0, over the second x minus the first x, 4 minus 1 equals 1 over 3. Do the same thing over here. Second y minus the first y, 3 minus 1, over second x minus first x, 4 minus 1. That was actually 3 minus 2, and this is taking me off, so 1 over 3 also. So the slopes between AD and BC are parallel, and because they have the same slope, obviously AB and DC are both parallel because they go straight down. So parallel, everything's parallel, so it's a parallelogram. Alright, so now we're into 6.2. What conjectures can we make about parallelograms? Well, first of all, what we're trying to say is that opposite sides are congruent. Also, we're going to try and say that opposite angles are congruent. And then the last thing we're going to say is that diagonals bisect each other. Now, opposite sides being congruent, we'd say this side and this side be congruent, also this side and this side. And then we would say opposite angles, so this angle and this angle would be congruent, while these two angles would be congruent. And then diagonals bisect each other. If I drew the diagonals in which connect opposite vertexes, or vertices I should say, what these two diagonals do is they bisect each other, so they're both cut in half. Property 1 of parallelogram is opposite sides of parallelogram are congruent. We have just covered that. That's our first conjecture. That's the first thing that we want to say about them. And then we're going to try to prove that using similar triangles. So we're given that ABCD is a parallelogram. So let's start this. Proof, statement, reason. ABCD is a parallelogram. So I know that AB is parallel to DC and AD is parallel to BC. Because that's the definition of a parallelogram. I'm going to just say P-gram for short. Now, if I were to draw in a diagonal going from D to B, what I have just done is I've drawn a transversal cutting through the top and bottom, and also a transversal cutting through the two sides. So what I can do is say that this angle and this angle are alternate interior angles if AB and DC are my parallel lines. I could also say that this angle and this angle right here are alternate interior angles if these are the parallel lines AD and BC. So I'm going to say that angle, let's start with this angle right here, ABD is congruent to its alternate interior angle, which would be this. I call this CDB. And that's because of alternate interior angles. I'll also say that angle, let's do this one, ADB is congruent to this angle, CBD, because those are also alternate interior angles. I can then say that BD is congruent to itself by way of the reflexive property. And that is enough to state that those two triangles, triangle ABD and triangle CDB, are congruent by way of angle side angle. And now I can state that AB is congruent to DC by way of CPCTC. Also, AD is congruent to BC by way of CPCTC. And that's how we prove that opposite sides of a parallelogram are congruent. Stop right there, write down this whole proof. Moving on, second property of a parallelogram is that opposite angles are congruent. Now, just looking at this, knowing it's a parallelogram, what I know is that this angle and this angle would be same side interior angles. So I'm going to say angle A plus angle D, and this is very informal proof. I'm just going to show it really quick. Angle A plus angle D equals 180 because they are same side interior angles. I can rewrite this equation as saying angle D equals 180 degrees minus whatever angle A is. I subtracted whatever angle A was from both sides. I can also say that angle A and angle B equals 180 degrees. So angle A and angle B, these two, because they're also, if I were to turn this sideways, it might be easier to see. But if these are parallel sides, and this line would be a transversal cutting through them, these two angles are same side interior angles also. If I wanted to, I could rewrite this equation as angle B equals 180 degrees minus whatever angle A is. So both angle B and angle D are equal to whatever 180 minus angle A is. Therefore, I can say that angle D is congruent to angle B by way of the transitive property. And that's it. That's my very informal little proof to show that opposite angles are congruent. Alright, so find the value of x in the parallelogram ABCD. Now I know that opposite sides are equal, so I know that I can set those two sides equal to each other. 3x minus 15 equals 2x plus 3. Subtract 2x from both sides. I'm left with 3 on the right side and x minus 15 on the right. Add 15 to both sides. X equals 18. Find the value of x in parallelogram ABCD. The second property of parallelograms is that opposite angles are equal. So what I know is I can set these two angles equal to each other. So 3y plus 37 equals 6y plus 4. I'm going to subtract 3y from both sides. Cancels out. I have 37 on that side and then 3y plus 4 on the other side. Subtract 4 from both sides and I'll get 3y on the right, ran out of room over here, and 33 on the left. Divide by 3, divide by 3, y equals 11. Property 3 of parallelograms, diagonals of a parallelogram bisect each other. For time's sake, let's skip this, but just know that when you see a parallelogram and it has diagonals, both parts of each of those diagonals are going to be congruent. They bisect each other. So going on with some questions that you might see. Something like this. It tells us that BE is x plus 1. AE is 3y minus 7. CE is 2x. And DE is just y. Now what I can do is I can say that DE, y, is equal to BE, x plus 1. And I would also say that 3y minus 7 is equal to 2x. Because each of these parts are going to be equal of each of those diagonals. So this is a little bit messy. What we know is that y is equal to x plus 1. So what I'm going to do to get this equation on the right, all in terms of x, in place of the y, I'm going to replace it with x plus 1 because that's what y equals. So this right here is going right there. So I'll have 3, and in place of y, I'll have x plus 1 minus 7 equals 2x. Now I'm going to simplify this. 3x plus 3 minus 7 equals 2x. 3x minus 4 equals 2x. Let's subtract 3x from both sides. And I'll get negative 4 equals negative x. X equals 4. Now if x equals 4, I can plug it in over here. Y equals whatever x is plus 1. That would be 4 plus 1. Y equals 5. This last theorem is really very simple. All we're saying is that if we have parallel lines, all of these lines are parallel, and then we know that one transversal is cut into equal parts between the parallel lines, then every transversal, no matter where you draw it, as long as it's a straight line cutting through all of those, the parts in between are going to be equal. So we have congruent segments. That's all there is to it. This is your homework. Sorry not there today. I'll be back tomorrow hopefully. And I wish you guys luck. Talk to you later.